I hope I'm audible to everyone. Uh, so I know it's very close to lunchtime. I'll try to keep it short. Uh, so most of the things that I'm going to talk about today are already covered during the sessions in the morning. So I'll probably cut that short and focus more on the speed that we were able to achieve for the TiDB adoption. Just to start with a quick intro, I am architect by nature, so I look after all things architecture at Elastic Run. Just a quick intro on what Elastic Run does. I think this is not working. Can you go to the next slide, please? Okay. So just a quick intro on who we are, what we do at Elastic Run. So we are one of the largest e-commerce network providers in the country. So if you are a customer, if you are ordering something from any of the e-commerce players, there is a good chance that the person coming to your doorstep is actually using our platform. Along with that, with the new quick commerce wave that is coming in, right, we are also trying to pave way to the entry for the new players into quick commerce, so existing large e-commerce players as well as the new D2C brands that are looking for a way to get into quick commerce model. They are something that we are also working with. Apart from the e-commerce world, we are also present in, or we work as distribution arm for the large FMCG distribution companies, FMCG brands. Our main focus area is the deep rural regions of India, typically with a population of 5,000 to 10,000, not more than that. Now, having the platforms built in-house for all the operations that we do for the e-commerce and the distribution business, these have been battle tested by our own operations team for last 7-8 years now. These platforms are now also available as SaaS offerings. There are a few customers that have already started using these platforms for their own operations. So in today's discussion, I am going to focus predominantly on one such busiest platform in e-commerce world, where the scale that we started with, versus the scale that we are currently at, there is a huge difference between what we started at and what we are currently at. Okay, sorry, can we go to the next slide, please? So I'll quickly run through the journey so far for the platform that we are focusing on. When we started, like any startup, right, the focus was on speed of innovation and scale. While we knew we will be scaling, the focus was to get the product out there as fast as we could. So we started with the low-code platform, which is a Frappe framework that we use, which is a low-code framework that allows us to build platforms very fast. We started with a very simple, the typical 3-tier architecture, right? Web tier, application tier, and database tier. So all of this on virtual machines, at the most 2 virtual machines at any given point in time when we started, for the scale that we started at. Now, as we grew, we saw the requirement for scaling, like we have heard in the sessions earlier. The typical way to scale is to first scale the web and application tier, and then so we moved the application tier and the web tier onto Kubernetes, considering the need for scale. We always knew that we will require the scale in future. So to be future ready, we moved all the web and application tiers onto Kubernetes. That provided us with capability of almost limitless scale for at least the application and web tier. 2 layers to worry less about, right? While the database was still on virtual machines, it was still able to cater to the scale that we were running at the point. As we scaled further, the requirement, the databases were becoming a bottleneck, and that is where we went with proven model, right? A CQRS implementation. We have one database that to which we write, and another database copy of the data from which we read. Again, a well-established template for scaling that we just implemented. The third template that we also again had with us, typically we will, in an application of, or the platform of that size, there are certain capabilities or features that are completely independent of the rest of the flow, which can be carved out as simple, smaller microservices, and the database can be federated out so that I have multiple databases to which we write, and they are more or less independent from a functionality point of view. So the database federation was another template that we implemented as part of the platform itself. The third piece, again, we were scaling very fast. As we scaled further, we required more and more scale, at least from the reads side of it. So there were a lot of commands, queries that were getting executed, which a single database read replica was not able to handle. Again, the same template that we applied, multiple read servers that were created, and at a framework level, we created multiple features which allowed us to do a lot of jugglery between the different replicas that could be used for different features. For example, there are certain analytical workloads that are okay to have a little lagged data. So that means I could have a delayed replica and use that for our analytical loads. For real-time reads, we had a separate reserved instances of MariaDB read replicas, and so on and so forth. So a lot of feature set that was added as part of the framework just to ensure that we have the right data available at the right time. Excuse me. Now all this was good, but you see, if you compare the picture on the left-hand side and the right-hand side, we started with only 2 VMs, and now we are running more than 100 different parts, some on Kubernetes, some on virtual machines. Again, like we have heard in the sessions in the morning, this actually leads to a lot of complexities from an architecture point of view, from operations point of view, from maintenance point of view, any downtimes, any issues with any of the databases going down. All those become a big activity from a maintenance or operations point of view. Again, the same kind of challenges that we saw in the earlier sessions, the same challenges we were actually dealing with for 3 to 4 years. Now, at this point in time, we felt that we have actually solved for the scalability from application and database, web and application tiers, but to some extent, we have also solved for the scaling on the read side. But the missing piece of the puzzle in the whole application or the platform was the writes, because we were seeing a lot more throughput and a lot more throughput requirements from the write point of view, and the hardware that we were using, while we had an opportunity or a capability to vertically scale that, we were sure that we will hit that vertical scaling, the ceiling for the vertical scaling at some point in time. Now, these were the numbers that we were working with as part of this. Now, T-3 months. So I'm going to focus more on the speed at which we adopted TiDB rather than going into the technology details of how we did it. And that is where I'm kind of going to focus more on the timeline rather than the technology aspects of it. This is where we actually got the projections for the next peak. So in e-commerce world, like we heard earlier, there are concepts of peaks where the e-commerce players have their sales that are live. The expected volumes are supposed to grow at least twice or thrice the BAU workloads. This is where we got the projections, and this is where we felt that the current stack that we have, while it is serving the current load, the projections are probably not going to, the stack is not going to work for the projected sales. Now that is where we started looking at multiple options for moving out of MySQL. Now, again, these are typically the most widely known or looked at options when we are thinking of scaling the database layer. Again, we did not do something that's out of the box, you know. We looked at the same different options that are available out there. So MariaDB or MySQL offers something called as Galera clusters, which allow us to do the scale horizontally. Sharding obviously is available out of the box. Application level federation was another thing that we were kind of thinking of, where, for example, if I can do a functional sharding, I can have multiple instances of application, each application catering to different functionality, while behind the scene, the data or the different application instances can keep in sync with each other. We also looked at some of the NoSQL options. Again, not all of the options are listed out here. There were a lot more options that we looked at. I've just listed down a few to to be representative. NoSQL was definitely one possible option, but like we saw earlier, the consistency issues and the operational complexity is something that was not favorable for NoSQL. One more issue, it would have required a full application rewrite just to make the framework compatible with the NoSQL databases, because the framework that we use works best or is created for working with MariaDB. That is when we started looking into distributed databases. Now, again, keeping the backdrop of the projections and the timeline of just 3 months at hand before the next peak is going to hit us. That is where we started looking at the distributed databases. Vitess is something that we had actually tried earlier about a year ago. And that is why we started looking more closely at Vitess first. We had not actually gone deep into TiDB at that point in time. This is again 3 months before the peak. Now, just getting started with Vitess itself took about 4 weeks. We did a few proof of concepts. We did some paper-based assessments on how good Vitess will be, how good it is actually in practice. We executed some performance tests on our cloud environment. We ensured that the required set of sharding keys are created or decided on. Having gone through the 4 weeks of proof of concept and the assessments, these are the different, again, I think we have seen these parameters earlier. These are the typical parameters on which we would evaluate any distributed database from when it comes to scaling. The ease of migration, impact on the application, administration overheads, how easily it can be scaled, what is the cost for hosting it, and what kind of monitoring it provides. When we looked at Vitess at this point, we definitely found it very performant. It was definitely able to handle the kind of loads that we were expecting. It was definitely possible to scale Vitess further. But there were a lot of issues when it came to monitoring, when it came to cost, when it came to scaling it effortlessly. While it is possible to do all these things in Vitess, it takes a lot of effort, or at least that was the outcome of the proof of concept that we did with Vitess. There was considerable effort in getting all these pieces to work in and getting them in place. Another issue that came with Vitess is the definition of sharding key. Again, just like sharding with MySQL, Vitess also does sharding, and from an application functionality point of view, we have to define or come up with the correct sharding key that will work for most of our functionality. There is no one single answer that works for the whole application, and we have to kind of make that as a compromise. Second kind of a big impact from our point of view, purely because the timelines were crunched. It involved a lot of changes that were required for making the SQL queries that were already present in the application to work or to be performant with Vitess, because the SQL queries will work, but if we update those SQL queries to be sharding key aware, then they will become much more performant with Vitess or any distributed database, for example, for that matter. So those were some of the challenges with which, because of which we felt that Vitess is probably not the right choice for us when we go or when we think about a longer term future for the platform. That is when we started reading about TiDB. We got more details of what TiDB has to offer, what architecture TiDB follows, what are the kind of use cases that people have implemented with TiDB. Again, this was all about 2 months before we actually thought about adopting TiDB. Still, the decision was not made to start using TiDB. This is where we started working with, getting our hands on TiDB. We actually deployed TiDB clusters. We did, again, the same kind of proof of concepts with TiDB in terms of performance, in terms of how easy it is to scale, in terms of how easy it is to monitor and maintain. And this was all done in a short span of 2 weeks. Because we already had a few learnings from our experience with Vitess, we were able to actually do this in 2 weeks. At the end of 2 weeks, just because of the rich feature set that we had seen with TiDB, we finally decided to not go ahead with Vitess and started planning for TiDB adoption. And that is where so this was the time, T-6 weeks, was the time when we actually decided to go ahead with TiDB. Now the war is on, right? We have a very strict deadline, very crunched timelines. We have to ensure that all our data, without losing a single record of data, is migrated from existing MariaDB cluster to TiDB. Now this is where we started thinking about what are the bare minimum requirements or what are the bare minimum actions that we have to take. The first and foremost is obviously to make sure the application is able to work with TiDB. Application is actually created for MariaDB. We have to ensure that it works with TiDB. Now there are very minor tweaks that we had to make, but yes, it was not zero effort. There are certain changes that are required to make an application written for MariaDB to make it work with MySQL in first place. With TiDB, it's a little more. So it actually felt like this, riding 2 horses at the same time, because we could not impact anything on production. Production had to still work on MariaDB while we start migrating feature by feature for each feature to work with TiDB. Now, different approaches that helped in this particular migration. The functional regression had 3 different, we approached the overall regression testing in these 3 steps. So breadth first is obviously what regression is all about. Deep dive into the specific use cases. For example, if a feature is migrated on TiDB, that feature was the focus of testing during that sprint. And sharding aware testing. So for example, if we know that the data for a particular use case is going to be across multiple servers, do my testers need to be aware of this fact, and do they need to change or add any new test cases for this particular piece? And yeah, like I said, these were iterative releases feature by feature, and slowly we made sure that the application now works with TiDB along with, without impacting anything on MariaDB. Okay, now code works, but is it fast? Because the whole reason we are evaluating TiDB is because we want to make it work faster than what MariaDB can. So we had our own performance test suites that we had used with Vitess. We had our performance test suites that we typically use for or before any peak that is planned. The same performance test suites were also executed against TiDB, but again, these performance test suites are simulations, right? They give you around 30 to 40% of confidence with, or 30 to 40% accuracy with the actual production workload. It's not easy to go above 40% of simulation equivalency when compared to production workloads. Now, that is where the team actually came up with this idea of traffic mirroring. Now this is again age-old technique which almost all web servers support for years. All we did was use the same technique and migrate and launched another application in production environment and ensured that every single request that is coming to the current production setup, which is on MariaDB, is also played on the second set of application via this mirroring at the web server layer. What this allowed us to do is, one, obviously get a much better simulation of production workload. While I won't say this was 100%, it took us to at least 80 to 85% accuracy from a simulation point of view for production workload. What this gave is basically a lot of confidence on TiDB as a product, not only from a performance point of view, but on the other aspects as well. So we were able to actually do a lot of testing in production environment by following this approach. Okay, so we have established that it does perform better. Now the next big and daunting task was to move the existing data, which was around 10 to 12 terabytes in size. While moving this data, we could not also lose any of the incoming data that was continuously being fed into the MariaDB. So the challenge was twofold. One is moving the existing data at rest and also keeping up with the changes or the new data that is coming in from the live application. Now there are multiple tools that are available for this. The TiDB toolset itself has a data migration cluster or dumpling and lightning kind of tools. We did try them out. To be frank, we didn't actually spend a lot of time on these tools, predominantly because of the crunch timelines and because we also had in-house know-how of Debezium and Kafka, which is an open source framework for specifically these kind of use cases. Debezium and Kafka work together in tandem using Kafka Connect, and that is a very well-established open source application that we can use for easy data migrations that we have been using earlier as well with MariaDB. So we decided to go ahead with Debezium and Kafka to migrate the data, the past data, as well as to keep streaming the new changes or the new data that is coming into MariaDB into TiDB. So that helped us to move the data, I won't say without a lot of effort, because we did spend enough effort for moving almost 40 terabytes of data from MariaDB to TiDB. Now, the data volume actually was only 12 terabytes. I'll come to why it was 40. Now, because we had very crunch timelines, not a lot of room to play around or not a lot of room to go wrong somewhere. So we wanted some kind of an insurance policy, right? That is where we decided to create, instead of 3 different TiDB clusters and seed all of them with the production data and keep them in sync with the production data. Now what that allowed us, so this was one of the key decisions for achieving or getting to where we are today in very, very short time, because that helped us reduce the amount of time that it took for seeding the data into 3 different clusters. Because Debezium and Kafka work in tandem, one single Kafka can now feed into multiple clusters at the same time in parallel. So we didn't have to wait for the data seeding to complete for the 10 or 12 terabytes of data that we had. Again, because we were using mirroring as part of our production simulation, one of the clusters we had actually earmarked as a throwaway cluster, which was used only for mirroring. We knew the data over there cannot be used for going forward as a production database, because it would get corrupted because of the functional intricacies of the platform. The second database and third database were the actual databases that we always planned to go ahead. One was kind of a backup in case something goes wrong for the second cluster. So yeah, this was one of the key elements that helped us go very, very fast when it came to production adoption. Now, we have actually ensured application works, it is fast, We have the data in place. We have the streaming in place. Now it's time to do the actual switch. Again, that switch was not done as a one big bang change. We took a two-step approach, again being a little cautious. First, we kept the writes happening on MariaDB. Now, because we already had the pipe going from MariaDB to TiDB, we just enabled the reads to go to TiDB. Again, the CQRS implementation in the framework helped a lot here. This ensured that because the kind of workloads that we run on the platform, the reads are much higher than the writes. I think that is pretty much true for most of the applications. So that is why the reads were first moved to TiDB. We again monitored for 3 to 4 days. And that's when, once we got the comfort, we switched all the writes, including reads and writes, everything onto TiDB. Thankfully, we didn't need the third cluster. Nothing went wrong in this approach, and the third cluster we were able to just get rid of. Now, again, this was the day on which we actually migrated everything to TiDB, but we still wanted to keep some insurance. That is why we still kept a MariaDB running, which was getting synced with TiDB. It was able to keep up with TiDB, but just because the volumes were already starting to increase. Now there was no coming back. So we had made our peace. We knew TiDB is going to work for us, and that is what we committed to. That was the time we also got rid of the MariaDB. That was our insurance policy. And since that time, so all this was done in 6 weeks, right from taking a decision to move to TiDB to this final switch. Now, mission accomplished. These are the numbers that we were running on the day of the migration. We have come a lot further from these numbers as of today. So this was about a month and a half back. And we are continuously working and monitoring on TiDB. We are now currently, I think, running twice these numbers without any issues so far. Okay, so everything is working in production. All the teams can go for 1 week holiday. Not really. So obviously the team was monitoring very closely on how TiDB is performing, what are the kind of monitoring or alerting that needs to come in place and things like that. But what we were also focusing on was the overall learnings that we took out of this whole exercise. While we spent only 6 weeks on this whole exercise, there were a few learnings that I think we should keep in mind or we should revisit. So one is the data seeding part, because the data volume, and I think most of the large database systems will only be the candidates to move to TiDB. So data movement of the existing data and the streaming of data will be one of the key decision points. So like I said, we did not spend a lot of time on the TiDB toolset that comes. And we went ahead with Debian and Kafka because that was what we were comfortable with and that was what worked for us. That does not necessarily mean that it will be the same for everyone. Everyone's requirements and the workload patterns will be different, and I think it's important to look at all the options and choose wisely. From a cluster sizing point of view, because of the speed at which we wanted to go ahead, we sacrificed cost versus overspeed. So we actually over-provisioned, and this is where TiDB team also helped in coming up with the capacity planning that would be required for the workload, and we just over-provisioned by twice that amount. So that helped us get rid of one of the variables in the overall migration exercise. Performance tuning, I think we are just scratching the surface of this. I think we have not explored enough of the different parameters that are available. Amazing set of documentation that comes with TiDB is helping a lot in this part. One of the key or one of the saviors that I would say for us was the key visualizer. I don't know if you have actually explored this, but key visualizer is something that has given tremendous visibility in terms of how the data is flowing and where the hotspots are for us to actually identify the issues with the application and fix them upfront. Okay, so I think that's pretty much what I wanted to cover, but before ending, I wanted to, highlight these players that helped us throughout this journey. Vitess, obviously, because that is what got us started on distributed databases. That is what gave us the insights into what are the possible pitfalls, what are the do's and don'ts when working with distributed databases. Ping-capting, big shout out to ping-capting, because what I'm being given to understand is this was the fastest adoption of TiDB ever seen. And TiDB team helped a lot throughout this journey, be it for capacity planning, like I mentioned, be it for suggesting performance tuning parameters without actually us going through all the documentation, or just even as a sounding board, just whenever we had some discussions or brainstorming. They had helped us and they have supported us throughout the journey. Very big thanks to the PingCap team for that. And obviously, nothing of this could have been done without the technology team at Elastic Run. So that is something that they deserve the credit for this. Okay, so this kind of covers the overall 6 weeks of execution that we did for adopting TiDB. A lot of midnight oil, a lot of sleepless nights, but in the end we were successfully able to roll out TiDB. Again, just to summarize, while this slide talks about what it did for Elastic Run, in reflection, we were able to do this because of, one, obviously the right architecture for the application. Without that, nothing could have been possible. Second, the right tool set, like TiDB and the rest of the tool set that we used. And third is obviously the right teams that we were working with. And needless to say, we are just getting started. There is no turning back. We are definitely going to see a lot more of TiDB in our landscape. Thank you.